Okay, now we have another theorem. This theorem seems like something we already knew when we first see it, but actually it says more. This is probably the second most powerful theorem we're going to get about polynomials. The most powerful theorem is coming up really soon. What the factor theorem says is that a number is a root if and only if x minus that number is a factor. So, a number is a root if and only if x minus that number is a factor. We already knew that we can use factors to find roots, right? We solved polynomial equations by factoring the polynomials. This theorem tells us we can go the other way around. And that's what this phrase, if and only if, means. This if and only if means if we have a root, we can get a factor. If we have a factor, we can get a root. When we go to prove this theorem, we have to prove it in two directions. When we say directions, we mean this way and also this way. We're going to start by proving that if we have a factor, that gives us a root. Well, if x minus r is a factor, well, we just said precisely what having a factor means. There's some polynomial, we'll call it q of x, such that p of x is q of x times x minus r. But then if we take p of r, well, that's q of r times r minus r. R minus r is 0, so that's some number times 0, right? Q of r works out to something, we don't know what. So p of r is 0. That's what it means for r to be a root. R being a root means the same as p of r is 0. Okay, so if we have a factor, that gives us a root. Now we're going to show the really new and exciting part. If we have a root, that gives us a factor. And if we have a root, then p of r is 0. According to the remainder theorem, though, any polynomial can be written as some other polynomial times x minus r plus some remainder, where the remainder is equal to p of r. Oh, notice, this is something we often do in math. Little r and capital R we're using as different variables. That happens a lot. In this case, the little r stands for root and the big R stands for remainder. Lowercase letters and capital letters are different variables. So p of x is q of x times x minus r plus the remainder. But p of r is just 0. So p of x is q of x times x minus r. But that's what it means for x minus r to be a factor. Right? There's something that we can multiply by x minus r in order to get our p back. So again, here's the end of the proof. And this time we actually are going to make some comments on it. What this theorem tells us is that if we know the factors, we can find the roots. We already knew that we could do that. But also, if we know the roots, we can find the factors. In reality, what we're going to actually do is kind of an interplay between those things. We'll guess a factor, and that'll help us find some roots. And then we'll guess a root, and that'll help us find some more factors. But one of the first things that this lets us do is it's one of our main ways of writing down polynomials. We can now write down a polynomial given the roots of that polynomial.